Hello everyone, thank you for joining my session, where we will learn how you can unlock the data lake with Azure Synapse Sql Serverless. My name is Veljko Vasic and I'm a senior program manager at Microsoft. Please take time to explore everything PAS has to offer. There are a bunch of free resources online at pas.org that you can use to benefit and learn from. Azure Synapse Analytics accelerates the time to insights across the data warehouses and big data analytics. In today's world, where the amount of data is exploding fast and keeps increasing even day after day, the time it takes companies to get to insights from this data becomes very critical for the companies to stay competitive in today's market. Azure Synapse Analytics brings exactly that. It accelerates your time to insights by bringing together the best of SQL, Apache Spark pipelines, and web-based Studio for building end-to-end analytics solution. Some of you are already familiar with what used to be called Azure SQL Data Warehouse. It has since then evolved into Azure Synapse Analytics. And on the left side of the screen, you can see what Azure Synapse Analytics, formerly SQL Data Warehouse, contains. It's a traditional data warehousing system that we today call a dedicated SQL pool. It's still available today for you to use in Azure. On the right side, you can see what the Azure Synapse Analytics workspaces that are currently in the preview bring. And it actually contains a bunch of things, starting from a Synapse workspace that is a single place that contains multiple capabilities. The first one is the dedicated SQL pools that we already mentioned, practically bringing those into the workspace. But in addition to this capability, there is a serverless SQL pool that gives you a serverless query endpoint that accepts T-SQL, and also Apache Spark pools. And that's not all. Across the capabilities in Workspace, there are features that are shared, like shared metadata. There is a common monitoring, security, and management layer, the pipelines used for data integration and orchestration, and also a bunch of connected services like Power BI, Azure ML, Cosmos DB. On top of all of this, there is a web-based IDE called Synapse Studio that gives you this single pane of glass to develop, monitor, and manage your analytics solutions using Azure Synapse Analytics workspaces. But let me jump right into the demo. On the screen, you can now see the home page of Synapse Studio. On the left-hand side, you can see the menu that you can use to navigate to different areas of the studio. And let me briefly go through them. In the data section, you can actually see all of the storage accounts and all of the databases that are connected to this Synapse workspace. Here are all of the databases, and you already saw the storages. In the develop section, you can see all of the SQL scripts and notebooks at a single place. So I can click here and open one of them, or one of the SQL scripts, or click here and open one of the notebooks that I previously already created. In the integrate section, you can see the pipelines. And these pipelines are used as a data integration feature to copy the data from one place to another, to transform it, to move it around, and so on. This is an example of one of the pipelines that I also previously created that copies the data and then runs a data flow. The fifth section is the monitor section. By clicking on it, I can go right into it. And here I can actually take a look at and monitor the activities that are happening on my workspace, like pipeline runs, Apache Spark applications, or the SQL queries that were executed on some of the pools. Here is an example of all of the queries that happened on New York City taxi pool in last 7 days. And you will see here on the screen all of the queries that were executed, and there is about 220 of them, as you can see at the screen here. All right, so here I see who submitted the query. I can see the query text by clicking on this icon over here. This was a very simple query, and so on. In the manage section, I can actually manage my items. So I can manage the analytic pools for SQL, both SQL and Apache Spark. You can see the list of my SQL pools. And what you will notice is the SQL on demand, also known as serverless SQL pool, is automatically sized and it's online, but I have several other dedicated pools that are here. Some of them paused, some of them already online. I can also take a look at the Apache Spark pools that exist in this workspace. There are several of them, and I can use this manage section in general to establish connections to other linked services from this workspace, to create triggers, to manage the access control and credentials. So let me go back to the home screen and show you how easy it is to get started with Synapse Analytics. So you see this banner up here asking me to explore the Knowledge Center. So let's go right into it. As I click it, the Knowledge Center opens up and it provides me with several options. And I just want to start immediately. So I'll go with Use Samples immediately. One click here, and I'll select Query Data with SQL. I'll click Use Sample, and the new SQL script appears with description of what I have here in the comments. I can just go and select this query and run it. It will start executing, and as it is executing, let me quickly explain what it does. It obviously selects top 100 rows from the open row set function, where we define the path towards the files. I selected, using these wildcards over here, all of the files in the 2019 year. I got the results back. I can see them right here. I can go on and execute other queries as well, where they look at the different data set, like holiday data. The first one was the New York City taxi, or the weather data. So all of this is available out of the box because all of this data is in Azure Open Data. I can also execute more complex queries, like this one, where I'm extracting year from a date. I'm counting the number of rides from the whole data set for a specific time period, from the year 2014 to the year 2019, grouping by and ordering the results. And let me go and execute this query. I want to show you one more cool thing. In addition to displaying the query results below, like you saw in the first query, Synapse Studio enables you to create charts immediately. So you can get from the table results into the charts in just few clicks. As this query completes, I'll show you how you can actually change from the table view to the chart view, clicking on this, and then choosing what we want to show on the x-axis and what we want to show on the y-axis. And here we can see from the New York City taxi data set what was the number of rides per year. I can also expand this view for easier viewing. Next, I want to show you how easy it is to get started with running Apache Spark jobs inside of Synapse. So let's go back to the home page and launch the Knowledge Center again. I'll use samples immediately, but this time I want to explore sample data with Spark. I select it and I click Use Sample. It opens up a Spark notebook that's already pre-populated and executed. So I'll just go briefly through the notebook. It opens up this open dataset from New York City Taxi. The second cell prints the schema, and here you can see the schema of the dataset. Then I execute a SQL job to group by the dataset and extract some of the aggregations. And at the end, I visualize the data that I got here. There are also instructions on how to clean this up once you are done trying it out. So in order to start this, I need to select the Spark pool on which I want to execute this job. And I simply click Run All. So this will schedule all of these cells to be executed, and it will actually start the Spark session. You can see here it's starting. To skip the waiting, I have sped up the video a little bit, and now my notebook is executed. And you can see all of the cells being executed and their execution times, and on what size of a Spark pool they were executed. Results are the same as previous times, and you can see all of it here. Alright, now let me go back for a moment to the Knowledge Center. I want to show you a few more cool things that are here. In addition to use samples immediately, you can go and browse the gallery of samples. So here we have a bunch of Azure open datasets that you can click on and start using immediately. There are the notebooks, which you can also use, and there are different of notebooks that you can use and start from. SQL scripts as well, and pipelines. So let's go back to the dataset and select one of it. So let's say this Bing COVID-19 data. I click Continue. It will show me how the dataset looks like, the brief explanation and the description, and I can click Add Dataset. Alright, now that this is done, I can see that the COVID-19 data from Bing appeared in the sample datasets. And as simple as clicking here and saying New SQL Script, select top 100 rows, I can actually start exploring this dataset. So from here, I can actually go further and filter out the data based on, let's say, confirmed larger than 1000. Just hit run. The queries go immediately, as simple as that, right against the SQL Serverless endpoint, reading the files directly without moving the data, and I'm already able to be productive and explore this dataset. Alright, let's now go back to the presentation to learn more about Synapse Sql and Synapse Sql Serverless in particular. In Synapse, there are two flavors of SQL pools: the dedicated SQL pools and the serverless SQL pools. The dedicated SQL pools are a traditional data warehouse. It gives full management capabilities over the data warehouse, and it provides predictable and high performance, especially for continuous workloads. It's optimized for the data that is loaded into the data warehouse, or as we like to call it, the managed data. The dedicated SQL pools are a great fit for continuous workloads because the loading of the data into the data warehouse gives you the governance and performance benefits. And if your workload is continuous and it's known to you, you can size the data warehouse appropriately for it to be cost beneficial. It enables high concurrency and low latency with rich caching and materialist views, and it enables you to do the advanced workload management where you can decide how many resources a certain query will get and prioritize one query against each other. On the other hand, serverless SQL pool is very easy to get started with. You saw in the demo, it was just a few clicks away to run my first query. It gives better TCO for ad hoc and intermittent workloads, and it's optimized for querying the data in the lake. As there is no need for loading the data, it's very easy to start and run, and you're charged only per usage. More specifically, you are charged per query executed, based on the amount of data the query had to process. If you don't run any queries, there are no charges. Serverless is not intended to be used for the dashboarding queries, so the millisecond response times will be hard to achieve, and today serverless works only on the external data, the data that is in the data lake. The major values of Synapse Sql Serverless are its serverless experience, it automatically scales, and it's automatically managed. You just walk in and run the query. System takes care of everything else. And the fact that it is fully pay per use. As I said, you are charged per query, per data processed. You don't worry about the resources, and you don't worry about charges when you are not running anything. In addition to its serverless experience, it greatly enhances the querying of the data lake. It's very fast, and some of you might be familiar with Polybase and the Polybase technology. So Synapse Sql Serverless inherited the Polybase concepts, but it completely changed the technology underneath. We actually built in the file readers directly into the SQL Server, leveraging the memory governance and thread governance of the SQL Server. So just that fact of removing the dependency on other applications that were used previously within Polybase to query the data in the lake gave drastic performance improvements. Additionally, it's very to use. We were very intentional with creating features that will make it easier to start querying the lake with T-SQL querying language. So you have things like schema on read, automatic schema inference, and variety of formats that are supported. There are a few scenarios where we recommend SQL Serverless on. So the first one is the basic data exploration. And this is the scenario where you are trying to explore the data. And if you ever asked questions that are on the screen, like what's in this file, how many rows are there, what are the max values, what is the last date that this dataset contains, all of these belong to the basic data exploration scenario. And with features that I mentioned that enable ease of use for querying the lake, this is very simple to achieve with Synapse Sql Serverless. The second scenario is the logical data warehouse. So this is the scenario where you are familiar with the data and you want to create a virtual SQL layer on top of this data for serving it to the downstream clients. With logical data warehouse scenario, you are able to join the data produced by various applications and practically all of the data in the lake and even in Cosmos DB and provide clients a SQL Server surface area for interacting with this data. The next one is the data transformation. So with Synapse SQL Serverless, you are able to run batches of distributed SQL queries to write out the Parquet files or CSV files. It practically enables you to run the query in T-SQL language and store the query results back to the lake. I wanted to share one of the prominent use cases we already see happening with Synapse SQL Serverless. It's very simple, but yet very effective. We have several customers that are using the Synapse pipelines to write the data into the lake from various sources. Either is the on-prem files that are being generated by the applications, or is from data coming from some sensors, or whatever. All of this data is collected with the pipeline and written into CSV or Parquet format into the data lake. On top of this data, we can create views so that Synapse SQL Serverless can read this data, and it can serve it to the clients, either the BI type of clients like Power BI or the tools that are able to work with SQL in general. For example, Azure Data Studio or SQL Server Management Studio. So let me actually show you how this looks like. Alright, I'm now back in Synapse Studio, and I want to show you how easy it is to start working with your own data. When you create a Synapse workspace, you immediately attach it to one of your data lakes, one or more. And you can actually, from the Synapse Studio, start exploring that data lake immediately. Here is the one that I attached. I'll go here and I'll select raw data file system. It will list out all of the folders that I have here, and I'm interested in the taxi data one. I enter it, and I see a couple of Parquet files here. But I actually don't know what's behind this data. And finding out what is in this dataset is just a few clicks away. I right-click on one file, new script, select top 100 rows. It opens up the query template that's populated with the path, and I hit run. It goes and reads the data. Alright. In this dataset, I only have few years available. So I'll actually use the open dataset account that has the full dataset available, and I'll use a little bit more complex query. So what I would like to point out is that the data set in Azure Open Dataset is partitioned by year, month, and then the individual files are in this month folder. And using these wildcards, I can actually use them to filter out the data based on the values in the file path. So with this condition over here, I'm actually looking only into folders that are 2014 up to 2019. The rest of the query is very familiar for people that are used to SQL, but in short, it extracts the year from the pickup date time. It counts the rides, all of the rides, and this is the condition I already explained, and it groups by the dataset based on year. So I can execute this. But what if I want to actually do something a bit more complex, and I actually want to use some of the BI tools to chart this out? So let's first craft the query. while this one is executing. So I'll use this file path function to extract the value from the path for a year. I'll use 2 for a month. I will remove the whereby condition, and I'll actually group by the year and month. Let's run this one. I forgot to comma here. Another copy-paste error. All right, let's try it out now. Okay, so while this is running, let's actually continue on our path to provide this data into the BI. So in order to do so, I'll actually need to somehow encapsulate this query into some view or an external table. And I can do that very simply. First, I'll create a database on Synapse SQL Serverless. I can click here and click Create Database. I want to create a SQL on demand, and I'll call it New York Taxi 2020, let's say. I hit Create. All right. I click to refresh the databases, and here it is. I can select this database now. All right, so now I'm in the context of this database. I'll write here create view, and I'll call it data. I'll say as, and just select it. In the views, I will not use the order by, so I'll just create this. All right, cool. This is now created. So if I go back to the Workspaces tab and I refresh the list of databases, I'll see the New York Taxi 2020 database I created. And when I expand views, I'll see the views here. Click on 3 dots, new script, select top 100 rows, bam. We have the T-SQL query. I can hit run, and all of the complexity of this open row set that I started from initially is now hidden behind this view. So this actually provides a very simple way to serve this data to downstream clients. So let me show you how you can do that. I will navigate to the develop section, and in here I'll go down to the Power BI menu. I'll explore it and I'll click on Power BI datasets. I can click new Power BI dataset command, and the menu on the right side will appear and it will show me which databases exist. I'll select the one we just created and I'll download the PBIDS file. I'll click here to open it. And what this file does, it opens up the Power BI with connection to the SQL Serverless endpoint already populated. So you'll see my Power BI opening up and asking me to select what dataset I want to load into it. This reduces some of the friction of like finding the connection string and populating all of this data manually, so that you can seamlessly go from the crafting, the logical data warehouse layer or this SQL virtual layer to actually creating reports on top of it. So Power BI opened up. It will ask me which credentials I want to use. I'll just quickly sign in. All right, and I have my SQL on-demand endpoint already populated. I'll hit connect. It is directly connected to the New York City database I selected, and I have my view over here. I'll select it. I'll click load. Now Power BI will ask me if I want to do this in the import or direct query mode. Let's go with import mode. And at this point, Power BI is issuing the query to SQL on-demand endpoint, querying the view, and it will start pulling the data here. What's really cool is that Power BI is completely unaware that the data is actually in files. Because in SQL on-demand, we created this view, and that completely abstracted the downstream story. So the Power BI believes it's connected to like a regular SQL server and it's querying a regular view. All of the heavy work of reading the files, like extracting the data from the files and returning it as a result is done on the SQL on-demand side. So here I have my data set loaded. So let's create one very simple report. I wanna see by year how many rides were there. That's it. From here, I can actually very easily publish this report. If I go publish to Power BI, yes, I want to save the changes first. Now I just need to find the Power BI workspace. I hit select, and it will publish my report there. So let's give it a moment. All right, all done. I hit OK. And now I go back to my Synapse workspace. Hit close here. And let me open up the Power BI reports. And here it is. My past report is here. I can directly view it from the Synapse Studio. But it's even better than just directly viewing it. I can also edit this Power BI report directly from the browser. So for example, let me include one slicer, and I'll use the year as a slicer. And here I can actually select the years that I'm interested in. So let's select only few years as an example. All right, I can now save this report. And that's it. So to recap, you saw how I started from querying the files, then using some of the easy to use functionality we built into the SQL Server language to query the files, and then creating a view on top of it to creating the Power BI report in a couple of minutes. Let's go back to the presentation to discuss about more advanced scenarios that you can use Synapse SQL Serverless for. Apache Spark, being part of the Synapse workspace, brings huge opportunities for delivering end-to-end analytical solutions. But what you see and can use within Synapse workspaces is not just the plain vanilla Apache Spark. So in addition to having the currently supporting the version 2.4, new versions of Spark will be added as well as they are released. Additionally, the way Spark is modeled in Synapse is more like a job service form factor, where when you want to do and operationalize some of the workflows in Spark, you can think about them as jobs that are being executed, and where the Spark pool doesn't play that big of a role, except defining the amount of resources that could be used to execute the job. Of course, if you're using notebooks, the session will start, and then after you are done, session will automatically close, and while the session is active, your pool is up and running, but auto-scaling as your workload is happening. So running Apache Spark is not a new thing for Microsoft. A bunch of code base is actually already shared with HD Insight. So we had years to learn how to support this service, and we are very familiar with it right now. On top of the Apache Spark, there is a bunch of innovations that came from Microsoft. So the background of this story is in Microsoft there is a huge number of experts in relational database systems and distributed relational database systems. So significant amount of folks joined this effort to actually bring their expertise in the relational databases and from the relational world into Spark. That led to a huge number of performance improvements, and at this point we are really very pleased with how our Spark pools are performing, and I believe you will be as well. In addition to that, there are multiple things that were added, like Microsoft Spice on top of this Spark, like Project Hummingbird that improves the performance of ML jobs. Then the cognitive services integration, where you can easily call in to cognitive services APIs directly from Spark in Synapse workspace. Then the project's hyperspace indexes, these are the indexes for the data in the lake, the .NET Apache Spark, and the Project Vegas, as you like to call it, for caching and shuffle services. So as you can see, all of these aspects really had a positive impact on the performance that Spark in Synapse workspaces provides. In addition to that, we were listening carefully during our preview, both private and public, to the customers, and based on that improved multiple things. For example, the notebooks and the UX around notebooks, the Scala experience is also pretty nice. The scoring wizard, support for Linux Foundation Delta Lake, creating MS Spark utils, which helps you with a bunch of helper functions that are frequently needed when writing Spark jobs. And the last but not least, the metadata integration with Synapse Sql. So this one is extremely important because it enables users to seamlessly transition from Spark to SQL for serving the data. So let me show you how the typical usage pattern looks like. So as in the previous example, a user is using the pipelines to write the data in various formats into the lake. But now you want to use the Synapse Spark to actually enrich this data, maybe run some ML models or just do some cleansing and transformation of the data. So once the data is enriched and stored as the Synapse Spark table, this metadata is automatically synced into SQL Serverless. So all of the tables you create in Synapse Spark are immediately available in Synapse SQL Serverless for querying. So let me actually show you how this example looks like. I'm back in the Synapse Studio, and I'll open up this Spark notebook. I already executed this notebook before, but let me walk you through what it does. So first, Cell will read the data, and this is actually a teaser for a session that will be one day after my session, where I'm actually reading the data from the Cosmos DB that I linked to my Synapse workspace. I will not go into more details than this. I will invite you to visit this session, and my colleague Arnold is doing it tomorrow. So we are reading the data from Cosmos DB. Then we are reading the second dataset, also from the Cosmos DB. And third, we are reading the data from the Delta format that's located in the data lake. So now I have all of these three datasets loaded, and I will do some joining of this data, all three datasets. I will clean up the datasets by eliminating unnecessary columns, and I'll fix the column types and prepare the data. Once it is prepared, I will do some additional cleaning for some specific criteria. That's done. Now I have here the schema, and I will create the table and save this table in my Spark database. Alright, so here I can execute the Spark SQL code. But the metadata sharing aspect that I was talking about is available if I navigate to the data section, then expand the Spark database, and I see the name of this table here. I click on three dots and I click select top 100 rows, and I can run the SQL query right on top of this data, even though this table was never created actually in SQL on demand. It was all done through Spark by merging a couple of data sources coming from different places. In my particular example, Cosmos DB, and the data stored in the Delta format. Alright, now in the same fashion like before, I can actually go and create Power BI reports using this table that was automatically synced into my SQL on demand endpoint. It looks and feels exactly like the previous demo that I did, so I don't want to repeat it right here. But I want to show you one more cool thing, and that is how you can actually leverage the existing SQL tools to connect to SQL on demand endpoint. Let me open up Azure Data Studio, and I'll establish a connection to my SQL on demand endpoint. This is the workspace name -on-demand.sql.azure-synapse.net. I'll select Azure Active Directory as a way to authenticate, and I hit connect. Alright, so I have established connection to my SQL on demand endpoint, and when I expand this list of databases, you will actually see all of the databases that exist in SQL on demand endpoint. And if you remember, this default database is actually created in Spark. So if I go and expand it, I can see the tables that were created in Spark immediately available here. And I can do select top 100. And as in the Synapse Studio, the script will open up that will query the first, in this case, 1000 rows from this external table. So this metadata syncing is happening automatically without your need to intervene. So it's a great feature that enables different roles to collaborate much easier together. We frequently see cases where we have the data science team that is creating the Spark jobs to enrich the data, and by storing it as a Spark table at the end of their job, this table is automatically synced to the SQL on-demand endpoint, so the business analysts can pick it up and start building reports directly on top of this. But I want to emphasize one additional thing. I connected to SQL on-demand endpoint using the Azure Data Studio client tool. And I can do so with every client tool that can connect to SQL Server, because the SQL on-demand heavily relies on SQL Server, and it enables all of these clients and a huge ecosystem around SQL Server to work with this endpoint. So for example, I can copy this query text, and I can right click on my table and say new notebook. This is a cool feature that Azure Data Studio supports, and I can add a text. Here is my query. All right, and then I'll add one code cell, and I'll use the one I had before. And you see I'm attached to SQL on-demand endpoint, and I can just run this cell, and the cell will execute the query and it will return the results. So in a similar fashion like the notebooks we saw in the Synapse Studio for Spark, I can actually see and use it immediately inside of Azure Data Studio for creating SQL notebooks. Now let's go back to the presentation and spend a few minutes on understanding how is SQL Serverless in Synapse charged. Synapse SQL Serverless is charged per query, and more precisely, per query per amount of data processed. The prices start from $5 per terabyte, but vary across different regions. And you are charged for the amount of data each query executed by rounding the amount of data processed to the closest megabyte, with minimum charge per query of 10 megabytes. The metadata only queries are not being charged for. Now, amount of data processed can be a little bit of vague metric, so I want to explain it in a bit more details. And the best definition we have so far is that data process represents the amount of data temporarily stored in the system while executing the query. So this includes the data read from storage, but also the intermediate results while executing the query and the final result size. Additionally, SQL on-demand, being built on top of the SQL Server, leverages the decades of work done in query optimization space for the SQL Server. To provide the best performance, we need to choose the optimal plan. And we choose the optimal plan by creating statistics over the data in the lake. With these statistics, we can select the plan that will perform the best and execute in the shortest period of time, but that will also process the least amount of data. So although creation of statistics is included in the amount of data processed, for the queries that you execute, they lead to reduction of the total amount of data processed because of choosing the optimal plan. So this includes the charges for Synapse SQL Serverless. There are separate costs as well, like storing the data in the storage, transactions that are happening on the storage, the network costs in case you are querying the data across regions. These are not included in this price that I was talking about for Synapse SQL Serverless, but they have separate meters going on for them. Given Synapse SQL Serverless is a pay-per-query service, there is an anxiety that exists about a surprise bill. We don't know if all of our workspace members will behave in an optimal fashion. So this anxiety that there will be a runaway script that executes a bunch of queries that lead to a huge bill is definitely present. So in order to give users the full control over their bill, we actually introduce the cost control feature that is already available. You can set it up through T-SQL, and there are few options you can choose from. You can set the limit on the time period, and you can select daily, weekly, or monthly time period. So let's see how it looks like in action. I'm now back in the Synapse Studio, and I'll go to the develop section. I'll click new. I'll say SQL script, and I will call this SQL Serverless Cost Control. Alright, and I prepared a few statements that you can see here. So first, I have this DMV that I can run to get the total state for amount of data processed in megabytes for the daily, weekly, and monthly time period. Next, I can use this T-SQL command to execute and see what are the existing limits. So no limits in place right now. And then I can use the store procedures defined here to actually set the daily, monthly, and weekly limits for SQL on demand. So I run sp set data process limit, type daily limit in terabytes, and let's put almost 1 petabyte as a daily limit. I hit run, this store procedure executes, and now if I go back and run the sys.configurations, filtering by the parameter name, I can see that the value for the daily limit in data processed has changed to 1000, while previously being this pretty big number over here. Alright, with this feature you can actually control the costs and eliminate the anxiety of a surprise bill that can come when using the pay per use type of services like SQL on demand. Let's now go back to summarize what we learned about Synapse SQL Serverless so far. Azure Synapse Analytics accelerates the time to insights by bringing together the best of SQL, Apache Spark, pipelines, and web-based Studio for building end-to-end solutions. Throughout this session, I tried to cover most of the capabilities of Azure Synapse Analytics, and we did touch upon Apache Spark, pipelines, and the Studio, and spent the most time working within the Azure Synapse SQL Serverless. You saw how easy it was for me to explore the data, to create views on top of the data in the lake, to share the metadata between SQL Serverless and Apache Spark, and to build the reports that lead to insights. Synapse Sql Serverless is pay-per-use capability that's charged based on the amount of data processed. If you don't run any queries, there are no charges. And Synapse Sql Serverless is ideal for data lake exploration and for building a virtual SQL layer over the data in the lake. This can simplify a lot of analytical solutions by eliminating a need to do the complex pipelines and ingest the data into some kind of relational system for serving the data down the road. Although the ingestion of data brings its benefits as well in the data governance and performance control, with this additional complexity that it requires. After you leave this session, these are the 3 key things I would like you to remember. Accelerates the insights, pay-per-query capability, and Synapse Sql Serverless is ideal for exploration and building virtual SQL layer. Please fill in your session evaluations. They really are important and will help pass and will help me improve my sessions in future. There are also prizes awaiting for you. Thank you one more time. My name is Veljko Vasic. I'm a senior program manager at Microsoft. Feel free to reach out to me through LinkedIn or Twitter, or by sending me the email directly at vvasic@microsoft.com. I would be more than happy to respond. Thank you all for joining this session. I hope you enjoyed it.